Thank you very much for this introduction. I didn't understand so much, but I hope you will understand me. But I understand that there also is some kind of translation. In October every year, there is so much, attention to what is going on in Sweden in a certain week. That's when the Nobel Prizes are announced. The world press is there. There's a lot of, many people are waiting for what will the outcome be. And many are disappointed, but a few are very happy. So what I will do here is that I will give the background to the Nobel Prizes. But I will do it first by, say the first third of the talk, to talk about Alfred Nobel, the man behind, in order to show you how the prizes came about and how he was thinking, which sort of made the prizes be what they are. And here are some of the pictures. This is the Nobel medal. This is the Academy of Sciences, where the decisions are taken. And this is from the banquet. I will show more about that later. So Alfred Nobel. He was born in 1833 in Stockholm. And he died in, this is what's up. He died in San Remo in Italy. And during these years, 63 years, he lived quite an interesting life. He was a chemist, he was an engineer, innovator, armament manufacturer, and he was the inventor of dynamite. And in physics, he has been honored by one of the elements, 102, calling nobelium. As I said, he was born in Stockholm. This is the street in Stockholm where he was born. These are his parents. This is from a painting. There's no picture of his mother. This is his father. So his father was what you now call an entrepreneur. He set up different kinds of factories, and he got broke and set up new factories. And in 1838, he got broke. His business in Sweden collapsed, but what should he do? Well, he went to Russia, to St. Petersburg. It's not too far from Stockholm. And there he set up a new factory, a new business. And the family was left in Sweden for 4 years. They had a very hard time. But once, he had been established there, he was very successful with a company called Fonderie et Atelier Mécanique Nobel. And there's even a picture of the house on where he lived in the Petrogradskaya embankment. This was a big house. They became quite rich. And so his father wanted his children to have very good education. They didn't go to schools. They had private tutors coming home to them. And he spoke Swedish with his parents, and sometimes with his brothers. He learned French. Russian, of course, he learned by living in Russia. And he learned English and German. And later on, he learned Italian. So he was a person rather interested in literature, but he also studied chemistry. He was interested in chemistry. He was interested in doing experiments. And at the age of 17, in 1850, his father sent him out first to Paris and then to the United States to study chemistry. It was rather brave, at that time, for a 17-year-old boy just to be sent out. Well, he had good, money with him so he could stay at good places and could get help. And this was a very important trip for him because he learned about nitroglycerin. It had been invented in Italy in 1847, and he took this knowledge back with him to Russia. Of course, he didn't, when he came back, this was in the Crimean War, and his father and also his brothers who were older were heavily engaged, in supplying the Russian army with landmines and such stuff. But then the war was over. The Russian army didn't need any of that more. And again, in 1859, that business went bankrupt, and they moved back to Sweden. There they set up a factory. Really, they wanted to produce nitroglycerin because they knew that the industry was coming up in Europe at the time. They needed to be able to blast away various things. So it was sort of a chemical substance that they realized would be very much needed in the upbuilding of the European industry. In 1864, they had set up a factory on an island outside Stockholm, in a lake outside Stockholm, and it exploded. 5 people got killed, among them his younger brother. So they were banned from, using this because, it was too dangerous. And then he made his important invention. So he found out that if you can incorporate it into diatomaceous earth, it becomes much safer and it's convenient to handle. And from that point on, they had very few explosions. This, which he called it dynamite, and he took a patent for that you could, play with, and it was almost completely safe. And now he had a patent on it. He was very industrious. He wanted to realize it, so he set up factories all over Europe and in the United States. The basis for him was in Paris, in a place called Rue Malakoff. The house is not there any longer. But there is a picture from his living room, or whatever it is. And over the years, he founded factories and laboratories in some 90 different places, in more than 20 different countries. Although he lived in Paris, but much of his life he was traveling between these factories. Victor Hugo, the French author, once described him as Europe's richest vagabond. When he was not traveling or engaged in business, he worked intensively in his laboratories. And he had been, he has somehow been working all his life. And at the age of 43, he was feeling like an old man, he thought. So he advertised for a secretary and supervisor of his household. He got a reply, and an Austrian woman came, Bertha. She had a very complicated name. She was a baroness from, her father had been a field marshal, but he had been in the Napoleonic War, so they had lost and he was becoming impoverished, so she needed a job. She had been working as a teacher in a von Suttner family, and she had been sort of having a love affair with the son there, and so she had to leave. She came to Paris, and they discussed she was there for a week, they discussed it, but then she left. But during this week, they discussed all sorts of things, and they became very good friends, and they were, after that, in correspondence. So what she did was that she went back to Austria and married this von Suttner, changed name to Suttner. Oh, I put it too quickly. I cannot take that away. And they lived their life organizing peace conferences. That was very, modern in the late 1800s. She also wrote a very famous book, Down with the Weapons, Waffen nieder. And as you can see, she was the one who, inspired him to set up a peace prize. And she was one of the first peace prize winners in 1905. After that, he met another Austrian, a young lady, whom he I shouldn't say had an affair with, but they were, she was somehow his companion for some time. It was not a very happy thing, but this is the closest he came to a family life. Eventually, she disappeared from his household, and then in the late 1880s, the French government was very unhappy with him because he was, selling weapons, but he was selling weapons to the Italians as well as to the French. And in the 1880s, there was big skirmishes between the French and Italian. Italy was a sort of newly founded country, unified country, and the border between France and Italy were, fought between. And so the fact that he sold weapons to the Italians made him that he had to leave France. And that's when he moved to Sanremo in Italy, which is very close to France. And he bought a villa, and this exists. So if you ever go to Sanremo, you should go to this villa. It's a museum these days. And at this time, he was experimenting with gunpowder. So he had a big cannon in the garden, because this was next to the sea. And he was practicing his gunpowder by shooting out into the sea. But there were fishermen there also, so they were not very happy with it. But so I think he had to stop with it. But the cannon is there. But he also, and also if you go there, of course in this villa, he set up a laboratory. He was still all the time experimenting. But he also he had been out of Sweden, for 25 years or so. And much of his, time growing up had also been spent outside. But he felt that he should have a basis in Sweden. So he bought some kind of factories in Sweden. This is the mansion. And this industry became also a very important weapons industry, making guns. During the World Wars, they were making guns to both sides. We were very neutral in Sweden. Here he had a lab. But this came to play a very important role in what's going to happen later. It was sort of, he was attacked because, he was making weapons, he was making gunpowder and dynamite. But he had this idea to say that my dynamite will sooner lead to peace than 1,000 world conventions. As soon as men will find out that in one instant whole armies can be utterly destroyed, they surely will abide by golden peace. We know how true that was. At this time, he was also, he had all his life a dream of becoming a writer. He wrote a play, and it was not published until 2003 with money from the Nobel Foundation. He was not as good writer as he was as an inventor. So he was one of the great inventors in the 19th century. He was awarded 350 patents, which was at that time, you know, a huge number. Because, you know, he was working in very small groups, and he was doing much of these things by himself. But of course, his best invention, something happened, was the Nobel Prize. And so in the 1890s, he was, you know, getting weaker. He knew that he didn't have much time to live. He was writing his will. He wrote several wills, but the last one was signed in Paris in 1895. It's rather short, and here I will just read a few of the lines for it now. I will, you know, emphasize part of it later. But he was saying that, you know, that all his estate should be invested in safe securities. That meant that they should sell everything, put it in safe securities. And the interest on which should be annually distributed in the form of prizes to those who during the preceding year shall have conferred the greatest benefit on mankind. And then he's listing, it says there are 5 equal parts. And the first one was should have made the most important discovery or invention within the field of physics. The next one was 1 part of the person who shall have made the most important chemical discovery or improvement. 1 part of the person who should have made the most important discovery within the domain of physiology or medicine. There is only discovery. So physics was discovery or invention. Discovery or improvement, it was discovery. And then 1 part to the person who should have produced in the field of literature the most outstanding work in an ideal direction. We can discuss that if you want. And then 1 part to the person who should have done the most or the best work for fraternity between nations, for the abolition or reduction of standing armies, and for holding and promotion of peace conferences. And then he specified who should, give out the prizes. And then the year after, on December 10, he dies in San Remo. He is alone in the villa with just some servants. And, but he had engaged an engineer as an assistant from 1890, a man called Ragnar Sohlman. He was only 20 years when he started. He was 26 when Nobel died. And he was to be one of the 2 executors of the will of Nobel. It was a very tough job. And because the other executor was a man in Sweden, so he was not doing anything really. But Sohlman got the message that Nobel had died. He got very quickly to San Remo. He saw the will, and went back to Paris to collect all the papers, all the fortune, because so much were placed in various banks in Paris, in Scotland, in Germany, And nobody else but him knew about this. He went around in Paris to pick it up. He said that he had 2 guns, when he was going around, but no one was attacking him because they didn't know him. He had to get all the securities out of France because in France they had very high taxes on these kind of fortunes. So he managed to get it all to Sweden, and that was a great achievement. So he did it before the authorities in the foreign countries knew of Nobel's disease. But then there was the next question: was he Swede? He had been living in Paris most of the recent time, or what kind of nationality? And France claimed, that it should be registered. All the fortunes should be registered in France, and it was a big legal battle. But he was saved, from the Swedish point of view, because he had bought this factory and a mansion. So he had an address in Sweden. And so this took years. The other thing was that, he was at the time fabulously rich, and he had his 2 older brothers were still in Russia. And they were also very rich because they had set up the Russian oil industry. And they might even have been, in 1896, richer than him. But they eventually lost all the money in 1917. They were not, they didn't manage to get it out. But there were other relatives who were, did not have any fortune at all. So they contested it. And then the king was furious because it was said, that the money could be given to foreigners. So the king, he called on this young man, to come up, and the king said, "You have to change it, but you cannot change the will like that." But he was upset because it says irrespective of nationality, which in the end, of course, was extremely clever of Nobel to do that. So, but it took 5 years about, 4 I should say, before the organization was in place. Because there was another thing, if one goes back to the will, there was no recipient of the money. It only said that it should be placed in safe securities. But there was no recipient. Usually when you have a will, someone has to get the money. They solved that by setting up what's called the Nobel Foundation. And the Nobel Foundation got the money, and they placed it in these safe securities. And then one could then go into more of the details. So who should be the prize awarding institutions? Well, in physics and chemistry, it was the Royal Academy of Sciences. In medicine, it's the Karolinska Institute. It's a big institute for medical research. And in literature, it was the Swedish Academy of Letters. And the peace was the Norwegian Parliament. And you might wonder what did Norway have to do with this? But Norway was in a union with Sweden at the time, and this lasted up to 1905. So somehow Nobel was thinking about them too. Then it turned out, that the Academy of Sciences, they didn't want to do the job. They said it's too much, how could we do it? But after some negotiations, they accepted it by the Nobel Foundation providing, enough resources for the job, so to speak. The Norwegian Parliament was the first to accept. They were doing it gladly. So in 1901, it all started. And again, you know, they were quite lucky, because in physics, the prize was given to Röntgen. He had discovered the X-rays in 1894. This was an extremely useful source of radiation, you know. It was already being used both, you know, for medicine and also in the lab for physical research. So he was the hottest man in physics at the time, and he got it. Also in chemistry, they made a very good choice. There was Van Toff, a Dutch, who was the strongest in physical chemistry. So Röntgen got it in recognition of the extraordinary services he had rendered by the discovery of the remarkable rays subsequently named after him. In many countries, it's called Röntgen rays. I don't know what you say here. So there was a big celebration. There were 180 people taking part in it, all men, and the king was not there. So we can come back to what are the criteria for giving it. And as you see, it says discovery or invention. So what is the most important discovery? Well, we can say what it's not. It's not a lifetime achievement. It's not the second discoverer who did it much better. It's not the one who did the most beautiful experiment. And it's not a theoretical discovery that has not been experimentally verified. This is sort of how the Nobel Foundation and the awarding institutions sort of interpreted what Nobel had said. And you might ask, why couldn't there be a theoretical discovery? Why can that not be given the prize? That is Swedish physics, Swedish research at the time. You know, we were a mining country. We had been, you know, we were very practical, very experimentally. The physics was very experimental in Sweden. There were very few theoreticians. But anyhow, as you see, it's not always the best physicist who gets the prize. You don't need to be an Einstein to get the prize. But as we say, it helps if you are. So let me say, it's not development. I give you some example from the beginning. Arnold Sommerfeld, he was a pioneer in the early quantum physics in the first 20, 30 years of the 20th century. He was an advisor to a number of laureates. He was a leader for a whole generation of German physicists. And he was actually nominated 83 times over the years, which was a huge number at the time, because every year, in the beginning there were 10, 20 nominations. Eventually they were up to perhaps 30 a year. But this has been discussed a lot. But you cannot pinpoint that he did make this big discovery that's needed. In America, John Wheeler, was a great leader, and was so advisor to many American physicians. But you could not pinpoint him either. So it's not for collected work. Einstein is a typical example. Because he got it, for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. Einstein did so many things. And at that time, he had already, discovered general relativity, his gravity theory. And I can come back to that later. Another of the giants in last century, Hans Bethe, he got it for his contributions to the theory of nuclear reactions, especially his discoveries concerning the energy production in stars. This is one of 20 fantastic pieces of work he did. But this is a big discovery, but he didn't get it for a lifetime. This is work that took him a few weeks to do, you know, when he did it. But it was a good price, and it was a correct price, according to the statutes. You don't get it for the most beautiful experiment, and this is a very famous experiment from 1959. It was published in 1960, the Pound-Rebka experiment. What they did was that they measured how the difference in how time is going, you know, from the first floor to the sixth floor of the lab building at Harvard in America. It's not a big effect, you know, you don't notice it if you go from here to that there is a difference in how time is flowing. It's an effect in that case of 10 to the minus 15, but they measured it. But, you know, what it did is that it confirmed the equivalence principle, and few mistrusted it. The equivalence principle is the principle behind Einstein's theory of general relativity. And it's a fantastic experiment. They used the technique of the Mössbauer effect. And Mössbauer got the prize, I think this year. So, not a theoretical discovery that's not been experimentally verified. You have all heard about Stephen Hawking and his paper, Particle Creations by Black Holes. It was a fantastic discovery, theoretical, and it's obviously correct. There are these days so many sort of circumstantial evidence for it, but it's not really been experimentally verified. Unfortunately, Hawking is now dead. He died, you know, a year ago, that was, I guess, the thing that he was regretted in his life most, perhaps even more than becoming sick as he was, that he didn't get the prize. But according to these statutes, the interpretation of the will that we have, it's not been possible to do it, to give him. A discovery should have scientific height. It should really be what we can say a watershed. In 1957, Chen Yang and Tsung-Dao Lee got the prize for their penetrating investigations of the so-called parity laws, which has led to important discoveries regarding the elementary particles. They had, the year before, suggested that the fundamental forces, the weak nuclear force, could violate the symmetry between left and right. People had, well, I should not say, I can come back to that. But I would say that 99.9% of all the physicists at the time believed, you know, that there is no difference between right and left in sort of the basic laws. But they proposed that there could be, and they proposed an experiment that could measure that in cobalt-60. And so this was from the summer of 1956. 15th of January 1957, Madame Wu, who was a very famous Chinese-American experimental physicist, published a paper showing that there was this clear effect in cobalt-60, that sort of electrons come out just in one direction. And if you look at it when you have some kind of in a certain magnetic field, and if you look at this experiment in a mirror, you will see that the mirror picture does not happen. So that was very quick. They were very young at the time. They were, 35 and 31. They're both still alive, getting by now pretty old. So Chen Yang as you know, is back in China. Sungdao Lee is living in America, and we can discuss that more if you want eventually. We like to point to one paper. This is Swedish Nobel laureate Hannes Alfvén for fundamental work and discoveries in magnetoaerodynamics with fruitful applications in different parts of plasma physics. I don't like this motivation because it should really be for one discovery. And it is for one discovery. And I will now show you the full paper that he wrote. It's here, half a page. And it might be difficult for you to see, but if you could really see it, you see it. Here is Maxwell's equation together with the hydrodynamic equation. It's just massaging this formula, and it gets a wave equation, and you can see, you know, the velocity, and you can put in values, and this is the plasma waves, the Alfvén waves, which are very important, you know, in the plasmas, what we have up in the sky, and well, quite easy. Just half a page, and you can get the Nobel Prize for it. We can also, last time I was sort of modifying this was probably in 2013. So this was a prize in 2013 to François Englert and Peter Higgs. And here we had the longest motivation ever in the prize for the theoretical discovery of a mechanism that contributes to our understanding of the origin and mass of subatomic particles, and which recently was confirmed through the discovery of the predicted fundamental particle by the ATLAS and CMS experiments at CERN's Large Hadron Collider. It's a very long motivation, but it said for the discovery of the predicted fundamental particle. But the prize was not given for that. The prize was given for the theoretical discovery of a mechanism. And what is this mechanism? In Englert's, he wrote it together with Robert Brout, but Robert Brout had unfortunately died 2 years earlier in 2011. They computed two Feynman diagrams, very simple, but they interpreted it correctly. They could easily have done it in a wrong way. Peter Higgs, he looked at electrodynamics coupled to it, a scalar field. This is all in what is called spontaneous symmetry breaking. You let the field, you have, say, two scalar fields. One of the scalar fields get a vacuum expectation value, which means that it fills up sort of the vacuum here. So he could, with the vector field and the scalar field, he could form another vector field, another field strength, and he got this equation. It's called the Procca equation, which is the wave equation for a massive spin 1 field. And this is exactly what one wanted. This effect means that you can have a vector field with a short range, because there is a mass term here. So that was a very clear prize, very sort of easy to motivate. And this is what the prizes should be about. This kind of discovery, this should be, you know, bang on them. So, what is now the procedure for doing this? Well, first of all, there is a Nobel Committee for Physics that has to work and prepare and, you know, do all the groundwork, so to speak. There's 5 regular members. There's a chairperson, and one can have adjunct members. We usually have 2, because 5 is too few people, because it's a lot of work. And then there's also a secretary, but the secretary could be one of the people in the committee. I mean, it's also a scientist, I mean, a member of the Academy of Sciences. So in 2013, it all started in September of 2012, where the Nobel Committee sends out invitations to thousands of people. Actually, around 3,000 letters go out to physicists all around the world, asking them to nominate persons who could get the prize. And so don't read so much. The idea is that every university in the world who have physicists should be on a list, and once in a while, you know, we send a letter to the dean or the president of that university asking for a list and addresses of all the physics professors. It's one of the list. But then there are also, you know, places like this, an institute. And there it's more difficult. They are not on that list. Then one has to have these people on a different list. So usually what we try to find a spectrum of people all around the world that could also be working in universities, but also trying to really, you know, ask people in institutes to nominate. And I can write it more, so split it up. So what I describe now is this. Then all the Nordic physics professors can nominate. That means, you know, physics professors in Sweden, Denmark, Norway, and Finland, Iceland, also. In the beginning, you know, there were a handful of professors altogether. Of course, now there are so many. So there's one. And also, the Nobel laureates can nominate. And some of them are very active, some of them are not. And also people from the academy. Even, you know, if you're a member of the academy and you have what is called various classes, you can be an economist or you can be a chemist can nominate in physics or vice versa, you know. So which means that, you know, some 3,000 letters go out, and we usually get around 400 nominations back. And we've never understood why there are not more. On the other hand, 400 is enough to work with, but, you know, people don't seem to take the chance. And some of these nominations are for the next neighbor, you know, or for someone we've never heard of. Of course, we have to check all the time. This could be, you know, some fantastic discovery that we have not noticed. But sometimes it's, we don't understand why they nominate. But what can we do? So the committee works in the following way, that the 31st of January, the nominations come in. Then the secretary puts everything together. And then we start to read every nomination. And then if there is a hot topic or some, you know, we ask for an evaluation. This could be by the committee members or some external members. And then they have to sign, you know, some confidentiality you know, report that they will never tell anyone that they have done this job. And sometimes we see I've seen on CVs that people that say that they have been experts. We don't like that. We don't ask them more after that. But then we can ask various questions. We can ask who should get it, you know, in this field, or is this field good enough? Is it high enough? Every year we ask for around 20 of those reports. And they come in at the end of May. And then during June and July, the committee has to write a comprehensive report on all fields. So this is huge work. Of course, you can reuse parts of what you wrote last year, but that work is usually sort of finished at the end of July. Then during August, we go through this report, and eventually the committee decides, you know, in the end of August, the committee decides this is the proposal for this year. Then it goes to the Academy of what's called the physics class. All the physicists in the Academy of Sciences then meet twice in September with 2 weeks in between and discuss it. And there are lots of discussions, you can imagine. So they can also recommend. So the physics class can propose something else from the committee. It really doesn't happen, but it could. And then in the end, the final selection is in the first Tuesday in October at the plenary session, where all the Academy of Sciences come and vote. And then there's a prize award ceremony at December 10. So the relation is that there could be maximum 3 laureates. It could be a divided prize or a joint prize. And the sum of money these days is 9 million Swedish crowns, like $1 million. And then the deliberations are secret for 50 years. This is a rule that has been, you know, introduced in more modern times. People probably didn't know, you know, when they were there in the committee in the 1920s or 30s and wrote what they wrote, that it one day would be open for scholars. And as you can see, as of 2013, there were 47 physics prizes have been given to one laureate, 31 to 2, and 29 to 3. These days, it's most often 2 and 3. There's very seldom that it's just a 1. So in 2013, in the September 11 was the first meeting where we discussed, this is what the book is called in Swedish. 25 was the final meeting. And then it's total silence. Then, of course, now there are about 40 people or so who know what it will be, and but have to be silent up to, at that time, October 8th. Then there is this presentation to the Academy, and there is the voting. And after that, the committee goes to a room and tries to get hold of the laureate. And there are many good stories about that, you know. So the Secretary General of the Academy calls and says, "This is a very important telephone call from Stockholm. Please do not hang up." And I can imagine that there are many other telephone calls that day, you know, that probably sound the same. So people are joking about it. But it's, and there are lots of stories also how people react to it. And sometimes you can be very surprised that people, you know, at 2 o'clock in the morning in California can be sitting next to the telephone. But I have good evidence for that. Of course, it's easier if it's this part of the world because you are ahead of us. That it's evening here, so that there was a medicine prize to Australians some years ago. They were the ones who had solved this problem with ulcer, and they somehow knew that they would get the prize. But they had made a point that they were always that day going to a bar in Melbourne or wherever it was. So they were sitting drinking beer there. And one day they got a telephone call to them there. Then in December, there's a ceremony where you have the laureates here, the prize committees, and the king and queen and whatever. Up here is the orchestra playing. And then for each of the laureate, there is someone giving a speech. And this is from 2008, when there were 3 Japanese. And this is how it started. And this is how it ended. I don't know if you can read Japanese, but I had practiced for a month, to say these things. And because as an honor, if there are Americans, you always speak English. If there are, Japanese, or if there would be Korean, of course one should say at least something in their own language. And this is what it said. Professor Kobayashi, Professor Masukawa, together with Professor Nambu, you have been awarded the 2008 Nobel Prize in Physics for your seminal work on broken symmetries, which have been instrumental for the modern theories of elementary particles. It's an honor for me to convey the warmest congratulations of the Royal Academy of Sciences. I now ask you to step forward to receive your Nobel Prize from the hands of His Majesty the King. There was just one problem, When I had said this in Japanese, only the Japanese knew that I had finished, because there were only these 2, and perhaps some of the Japanese in the audience. The king didn't understand it. So he was just sitting there, and I had to make, signs, that it worked out. It was not so bad. Then the king raises, and then they give the diploma. And they also then get a diploma like this is what the diploma looks like. Now there's a medal, and then there's money transferred to their bank. However, at that year, Professor Nambu couldn't come to Stockholm. His wife was sick. He was still, he was 87 years old at the time. But fortunately, Chicago is 7 hours after Stockholm. So what we can do is that the Swedish ambassador to the United States could give him the prize in Chicago at the university. And during these 7 years, could transmit, that part of the ceremony and my speech, and I had provided them with an English translation of what I said, because most of the talk was in Swedish. So that could be given in great style. And it was a very touching moment, because Professor Nambu is one of the most loved scientists in the world. He was such a gentleman, a very humble and fantastic person, really. And when I got into this, so much I can, of course I'm not supposed to give any secrets, but so much I can say that when I got involved in this work, I had this dream, that I one day would be able to stand there and give it to him, because he was certainly one of my favorites. And I couldn't, but then also when we called him in the morning, I was going to, congratulate him, but I was so moved by it, so congratulations, I could only say. But I had congratulated him later. So after the ceremony, there is a big banquet. It's a bit bigger now than in the first year. There's usually around 1,350 people. Now the king and queen are, of course, central. And then for each prize, one of the laureates have to give a short talk. After that, it ends up with some dancing. So that's the end of that evening. So during the banquet, there is one table, where this is I shouldn't have shown it. This is the queen, and the queen always sits next to the oldest physics laureate. This is the queen to be. On the other side is the king, and somehow he was sitting next to the medicine laureate. So this is, we, who are, more ordinary people, we are sitting at the tables. So this is what we see, we're sitting behind. But from the front, this is like, so this is when David Gross, you see, he was very happy when he sat there. This is from when François Englert came, this is a good. All the laureates, they have an attaché, someone doing all the job for them, telling them exactly what to do, and they're getting so spoiled. So the laureates get so spoiled, during this week that, they have a limousine for them, which is just driven up when they're going somewhere. And there are parties and there are, meetings or lunches and dinners every day. And it's this story that there was one laureate, he had been driven around for a week in this big, huge limousine. He comes home and he should go to work. And he goes to his car and he sits in the back, puts himself in the back seat. So, so this, you can probably not see that. It's not so good here. This is the François Englert's diploma. This is supposed to symbolize spontaneous symmetry breaking. This was the artist's view. I was trying to explain it to her, but well, it's a nice painting. Nobel had this idea that those who were given the prize should be independent for the rest of their lives. So, this is the amount, in nominal value, and this is sort of the monetary value as of 2007. And you can see that it fell, and here was, in 1960, the prize sum was not that big. That was because all the wealth of Nobel was placed in safe securities. And around 1970 or so, they got allowed to invest, on the stock market and in the house, market, and then, it gone up very much. So again, it's a good size prize. So let me end by now coming back to Einstein. If there is a site called nobelprize.org where you can go and check, and there, if you really are good at, you can see who nominated who. Well, up to up to 50 years from now, so you can see what happened during the first year, and you would see that after 1916, 17, Einstein was very heavily nominated, and even so in 1921, the committee could not decide to give it to him. It was even so that he had already promised his wife, whom he had divorced, that she would get the money. So that was part of the divorce settlements. And it couldn't be sure. But in 1921, they could still not decide. So in 1922, there were two prizes. One was for 1921, which was given to Albert Einstein. And then the one for 1922 was given to Niels Bohr. And this is the diploma for Nobel. And you cannot read it, but I will tell you what it said. It says, independent of the value which after a possible confirmation may be attributed to the theory of relativity and gravitation, give the prize which for 1921, blah, 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 for his contributions to theoretical physics, especially for his discovery of the law of the photoelectric effect. This is rather shameful, that it's, independent of. So they were sort of, washing their feet. They couldn't really give it for that. It's like if, even in 1927, when it was Compton, they couldn't give it, for sort of proving that the photon is a body. It's talking something about radiation, blah, blah, blah. So, anyhow, but in 1922, Einstein was going on a world tour. Well, he was going to Japan for a long, and he was going to leave in October sometime. So I think on the 6th of September he gets a letter from Svante Arrhenius. He was the first Swedish laureate. It was a physical chemist. He got it in chemistry, but he was in the Nobel Committee for Physics for many, many, many years. So he wrote to Einstein saying that we hope that you can postpone your trip a bit and not, because we would very much like to see you in Stockholm in December. When we heard about this, we were very surprised because we thought that you should never say anything. But the point also at that time was that the date when it was announced was in November, so it was much closer to the. But anyhow, Einstein did not postpone his trip. He went to Japan. On the ship over, he got the telegram that he had got it. So then it turned out there was a problem. So who should get the prize? Who should be there to get it for him? So then the German minister, or ambassador at the time, said he actually, because he's a German citizen, but he had not lived in, well, he lived in Germany for the last, 5-6 years, but he had lived in Switzerland much longer. So the Swiss ambassador said, no, this issue. In the end, the German somehow won, and he took it, and there was eventually a ceremony, like for Nambu, for Einstein in Berlin. But then in the summer of 1923, he came to Sweden. He came to Gothenburg, my hometown, where there was a physics conference, and he gave his Nobel speech. And if you can see, this is the Swedish king sits here. This is Arrhenius, I think. This guy here is sleeping very well. And I don't know if these ladies and men behind here, how much physics they knew. They were probably there just to see him. And you might ask me, what was his Nobel talk about? Of course, about general relativity. So he's the only one who has given his Nobel speech in Gothenburg. And as we say, I always think that's enough, we don't need any more. Einstein did it with us. So thank you for listening.